over this, there's one question before you get to a question that looks like this entirely. The first question that you'll see on this objective, they'll give you the lines initially. So you'll see something, well, we can just graph these right away. So I've got my -3 down here for the y-intercept for this guy. And then the -1/2 is telling me down 1, right 2. So that's going downhill, left to right. And then I can go uphill, up left, up to the left like that. And it's a solid line because it's equal to as well. So, boop, 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 boop. Okay, so that's one line. I'm also going to graph the second line, and I'm just going to change that to a red though, -3x. So I get -7y is greater than -3x plus 21, -7. So y is less than, because we divided by a -3/7x minus 3. So again, we start at the -3 part, so -3, so same y-intercept, up 3, right 7. So up 3, right 7, down 3, left 7. And since it's not equal to, there's no bar underneath it, I'm going to do a little dotted as best as I can. Oh my goodness, look at how beautiful that is. All right, so this is what your first problem will look like. It'll show the two lines, and you have to determine where it's shaded, where's the solution region. But it's going to ask you to do so using ordered pairs. So for example, if I were to look at this first ordered pair, 16, -4, this gives me an x and y value. I can plug that back into the original inequalities. So this is going to be y, so -4, oh, hello. -4 is less than or equal to, so I'm doing this first one, -1/2 times the x value, which is 16 minus 3. So back in here, when I simplify down the right-hand side to get -4 is less than or equal to, that's going to be -8 minus 3, so -11. That is not true. So therefore, that is for sure not a solution. So when I look at the graph, 16, -4 is somewhere over here. That region is not a solution region. So then I can keep going. So then the second one, let's look at this one here. So when I plug in -14 and -3 into the inequalities again, I get -3 is less than or equal to -1/2 times -14 minus 3. So is -3 less than or equal to, that'll be 7 minus 3 or 4. That's true. But wait, there was another inequality that I have to check. So 3x, so I'm looking at the second one now, 3x minus 7y is greater than 21. So is 3 times -14 plus, oh no, minus 7 times, come on, Ms. Hellier, times -3 greater than 21. Well, let's see, this will be -42 plus 21, which is -21, and that is for sure not true. So you have to check both of them. So both of these I know are not true. When I go to -14, -3, it's somewhere over here, and that's still not a true region. So it's either going to be in this region or in that region. And one of the points will be a solution. So you will have a yes to both inequalities. But let's look at the shaded region method. So when I look at this second inequality, it shows me that it's less than, which means that it is below the line. So for the dotted line, I'm going to be shaded below. I can also use the test point of 0, 0. It should be false because it's not in the shaded region. So when I plug in 0 and 0 for x and y, I get that 0 is greater than 21, which is not true. So that's another way you can check and see if you're shaded in the correct region. So same idea with the second inequality. Once again, it's less than, but let's use purple so we can really emphasize it. So it's less than this region right here, which means that the solution is this entire section down below. And on the test, you can super duper bold it in, but I personally am a fan of really making sure that we have a big old dark S in the middle, or that we have an arrow pointing out that this is the solution. Something like that is fine. So the last part, before I go into this one, I want us to switch over. So this is a time to hand out your exit tickets, and I will come back with a different video for this one. So grab your exit tickets.